what are some of the ways these diseases are transmitted? How do we track infections? Okay, and then we'll talk about global health, so including the initiatives of the CDC, which I don't know at this point where we are, but any other institution that is trying to sort of track how diseases spread, especially those that are emerging, infectious diseases in general. So what does this mean to you? Say that you don't speak English. What does this mean to you?
Toxic.
Biohazard.
Don't touch.
Yeah.
Toxic.
Toxic. It's, yes, danger, right? The color alone is telling you something, right? Don't touch it.
What?
Right? So, so there is a universal language that had to be developed by epidemiologists to understand and communicate how diseases, all of the characteristics of diseases and how they spread and whatnot. And so you don't need to know English to see that, right? Anywhere where you are, when you're watching a movie and you see this sign, and maybe it's yellow or red or orange, right away you're like, oh, we're really studying with a virus that is deadly or whatever. All right, so some of the things that epidemiologists deal with is how diseases or what diseases are caused by. They try to investigate what was the cause of that outbreak, for instance. They have developed methods or protocols that they suggest, they advise the public, and especially the people that post the money on how to protect the public from these diseases that are infectious, that are virulent, that are spreading. And so the way they do that is they do studies. There are 3 different, maybe a little more, types of studies that they do. And they collect data, they do interviews, they do testing in labs and stuff. And they plot that data, their findings, in graphs, right? And also in other graphs and diagrams and stuff to educate the public and to show evidence of their studies that back up, their claims. And so that is used by governments. That data, all of those graphs and stuff are used by government officials to allocate monies to wherever they are needed in terms of keeping the population healthy. So there are certain diseases that are notifiable. Not every disease that is bacterial or fungal or whatnot are notifiable. You get some fungal infection in your nail, you're not going to go to the hospital or is that notifiable disease. No, that's probably something that you can, unless you have a very weak immune system and have underlying conditions and it really spread and got really bad, then you go to the hospital and the hospital officials, they're supposed to notify the city agencies and then CDC and the appropriate authorities about this, because maybe it's something, in this case, it's something that you have in your nail. Unless you go from one nail salon to another without disclosing that you have that, you may be spreading it, right? But it's not something like Clostridium difficile or anthrax or, give me another example.
Giardia was on.
Giardia. these are notifiable pathogens that cause diseases that are notifiable. And so we have these, and again, I'm not sure if they still have them, and CDC. I know New York City and other states and other places have implemented data banks and information sort of websites that play the role that CDC used to do for notifiable diseases and stuff. I don't know if I shared that with you, New York City Department of Health. I'll share it with you guys. So where you can see the current state of viral and diseases and the outbreaks and where are they happening and anything related to the disease. So these reports are morbidity and mortality reports. Yeah.
All antibiotic resistant diseases are notifiable? Like,
all
like vancomycin resistant Staphylococcus?
Pretty much, yeah, pretty much. Because it's something that presents a risk to the population. So the morbidity is the number of cases, right? Number of infections in relation to the total number of the population. Usually these numbers of morbidity and mortality reports are based on or taking into account the population number. So it's usually a fraction of the population that is infected, that is dying of that particular disease. So those numbers are usually given in that way. So Richard mentioned earlier when I asked what did epidemiology and disease mean, and he said incidence and prevalence. And so these are two terms that are used constantly in infectious diseases and by epidemiologists and health-related areas where we're looking at the number of cases, both mortality and morbidity together, and is again used as a proportion of the population during a specific time or specific period of time. Prevalence is the total number of affected in the population and is expressed as a proportion. And this one takes into account both the old cases and the new cases. So I think I may have mentioned about smallpox being the deadliest disease that have killed over 300 million people since recorded times. And that includes throughout time, right? Not just one particular time, but throughout our life. So here we are looking at the incidence and prevalence of HIV. And HIV has not disappeared. So we have the prevalence is the old and the new, right? So from the 1980s to 2010, these are already like 15 years old, but for some reason, it's hard to find some of the statistics of some of these diseases. But this is just to give you an example of what these two terms mean. So here we have the incidence, which is the number of cases from 1980 to 2010. So it is, so for instance, if I said the incidence of COVID-19 was higher in New York in March through June 2020, right? So looking at that period of time, right, between March and June 2020, the number of cases, and again, I'm talking about the mortality, the morbidity and the mortality. And so here I could say the number of cases of COVID-19 has surpassed the 7 million deaths since we heard about, or since the first outbreak in China, worldwide that is. So diseases can be characterized or categorized based on where they occur geographically. So you can have a sporadic disease where diseases occur occasionally, you know, without really taking into account or the geographical area plays so much a role because it's just one sporadic case. You can have something like bubonic plague, right? Bubonic plague doesn't happen really anymore. But then you have sporadic cases here and there, maybe in isolated areas around the world, maybe in the desert, the Sonora Desert, or you know, in areas like that. So it's very rare, it's very sporadic. An endemic disease is one that is constantly present in the population. So can you give me an example of a disease that is constantly present in the population? Even if we don't have like high peaks, maybe we have like this, going, you know, case here and there, maybe a lot, and then coming back to
Like tuberculosis in other places.
Which one?
Tuberculosis, like in India and Southeast Asia.
Yes, so that one is present all the time. Even though you may not have cases, many cases all the time, but it's in the population. And at any time, it will pop up and you get 5 infections here and 100 infections there, you know. And this is more, you do look at the geographical area and the time where it occurs. It could be during a short period of time. It could be as a result of weather. It could be as a result of travel, you know, some of those human activities that may increase, not just human activities, but even natural causes such as climate change. And this will tend to increase the cases. If it's rainy season in South America, for instance, during rainy season, maybe that will increase the leptospirosis, also an increase in the population of mosquitoes that will carry yellow fever virus, things like that, right? So weather has a lot to do, especially for those tropical diseases, seems to be very much connected to some of these outbreaks. And so we also have epidemics, and epidemics are on a larger context. So we have the AIDS epidemics in the 1980s, 90s here, right? So it started, or at least it seems to have been started here in the United States. But then you see after many years that it has spread to other continents, again, because of human behavior. But it was an epidemic at the beginning because it was just in this area. It was a large area, but it was in this area. It did not cross any land masses or oceans. It became more now like a pandemic, right? Which is not, it's not very similar to the pandemic we just experienced, but still a pandemic because it is spread throughout the world, right? So it's in Africa, it's in Brazil, it's in here. So that has not disappeared. But a pandemic disease is one that it infects or it happens in different areas of the world. So I have this little thing that I'm going to play for you, and it shows the different types of diseases, whether they are endemic, whether it's an epidemic or a pandemic. So let's see if you can hear it, right?
Existing cases.
Ready?
The expected prevalence. The prevalence of a disease is the number of cases, including both new cases and previously existing cases. The expected prevalence of a disease is the prevalence that's expected based on patterns established by past observations. The incidence of a disease is the number of new cases over some period of time. Let's see how epidemiologists use prevalence and incidence data to evaluate the status of a particular disease. A disease is sporadic in a region if only a few cases occur in that region. A disease is endemic in a region if it normally and continually occurs there at a fairly stable rate. A disease is epidemic in a region if it occurs there at a rate significantly higher than would be normally expected. A disease is pandemic if it's an epidemic on more than one continent at the same time. Now watch the incidence and prevalence data and see if you can recognize when an epidemic or pandemic occurs.
What is that?
Track for epidemic and pandemic.
All of them. Sporadic, endemic. If it goes above the threshold, then those are endemic. If it doesn't go. So this is it,
Pandemic.
pandemic. If you see one bar going above the threshold, then that will be an
Epidemic.
epidemic. And then the other ones are more endemic, like there. Right? And then sporadic, you have, once in a while, rare occurrences of a disease. All right. So, other things that are used by epidemiologists are thresholds, right? So, for instance, here we see a baseline. It's called the seasonal baseline, okay? Where, and here we're talking about influenza, the morbidity and mortality. So it usually happens to affect this many people in terms of deaths, right? But then, depending on the strain, some years you get strains that are really, really virulent, and the vaccine may not be as effective. Again, you have to account for underlying conditions of the patient. And so you have years where the mortality may increase due to these particular factors. The virulence of the strain that is attacking, and also the number of people, elderly or people with underlying conditions and stuff. So here we see that the blue line is the epidemic threshold. So these are set by using observations and data from previous years. So all of these years, they have had more or less this number of cases and mortality in terms of the blue line. But the red line is the actual mortality, and in certain years, you have these peaks that are really crossing, or they go above that threshold, the seasonal baseline and the epidemic threshold. So you see here in 2004, we have a pretty high peak, and then it sort of goes down again between 2004 2005. It goes up again in 2005. During these 2 years, 2006-07, listen, the mortality rate has decreased, probably because a lot of people got sick. I mean, you got a herd immunity. You also get more people getting vaccinated with the flu shot and stuff. But then you get a new strain that is causing another peak in 2008. So these are things that we can rely on, because this is actual data that we can look as models to sort of predict and prepare for future epidemics, because this is not going away. I mean, every year we have flu, we have influenza, and we have complications with pneumonia and other things that are of respiratory nature. So these diseases, again, if they are a threat to the population, then they need to be, they're notifiable, and they are notified, like if you are a nurse, you probably, any of you working with,
If I give someone a TB, to look in, and if they have a bump, I think like more than 5 millimeters, and I have to get notified to get an X-ray, and if the patient has cavities, TB cavities, and active TB, then you have to report that.
so you report it to your boss,
Yeah. And they report it to the State Department of
to
Health.
the state, and then they're supposed to report it
To
to CDC. I imagine, I hope that that's still the case. But, and then worldwide, we have the World Health Organization, and when these entities get together, you know, they share information, and they can really provide enough information worldwide in terms of where these outbreaks are happening.
In the wintertime, in the fire department, like you do your paperwork on a computer, and they add a field that says if it's flu related, like, so you can check it. I don't remember exactly what it says, like, is this flu related? And then if they can collect data. So if they start seeing that, because the symptoms of flu are very nondescript. So when the city can go and look and say who had a heart attack, so they can see what's happening, and if they search by flu, then they can pinpoint if it's like starting in a certain area. I don't know.
Yeah. So, and imagine if it wasn't like that. I mean, this started very early on. It started with, early when we look at the historical aspects. When people started getting sick and passing it on to others and infected others, that became a problem. So this is actually, and remember contact tracing? I remember somebody called me, you were exposed and you were this and that, and they asked a bunch of questions. And I think because of all of those very aggressive measures, I think we were able to stop so many cases from developing, from more people getting infected when COVID. So it has a lot of value to notify about these diseases. All right, so we have different types of epidemiology. We have descriptive. So we have a couple more, but let's go about descriptive epidemiology. And so this one here, it it gathers information through interviews, through medical records. So it looks at where the disease has been detected, the number of people, it follows those people who have they been in contact tracing again, who have they been in contact with. And it's basically a study done by the epidemiologists, but it doesn't involve anything that is experimental. This is mostly data that is gathered from people that are infected. And so this may also include, other aspects, such as the history, such as history of the people in that area, even looking at the infrastructure of a city, and the water supply and other things. So here is the pioneer of that type of epidemiology. This is John Snow, and he was a physician. Are you guys familiar with him? Anybody heard of him before?
Oh yeah, it was like all this waste being dumped into the different paintings, and it was like this section of the city was downstream of it, so all this pure water was going into the people's home thing, was drinking from it, and it was got sick and died.
Yeah. So this is in England, and the guy was a physician, and so what he did was he started mapping every case. So this is London, and these are households, okay? The black dots is where every case was located, and he documented all of this. And even if, let's say someone living here traveled to the outskirts of the city, so he interviewed the households, and he followed them to wherever they went to see if they were spreading the disease. So he documented all of this, and he basically provided all of this information, and ended up concluding that where the infection started, or where people started, was in Broad Street. There was a water pump there where people used to go and pump the water, and so they got sick, and some people died. So there's also experimental epidemiology, and this one uses laboratory or clinical studies. And so this is probably something that you can relate it more to a clinical space where we have a lab, right? Or anything where you go to the doctor and maybe the doctor decided before giving you antibiotics, or even if he gives you antibiotics, to take a sample. And then they send it out to the clinic, to the lab. And so this involves that type of study. And also, it could include humans, it could include animals. But the study at the end, it provides the causation of the disease, or tries to pinpoint at the causation of the disease. And that's the goal of all of these types of studies. But here's a good example of that type of study, which is, I think I may have mentioned this guy at the beginning, right? So he implemented what the midwives were implemented on their side of the clinic, because his side of the clinic had just too many infections, too many people dying, or women and babies dying from infections. And so by simply applying whatever the midwives were doing, which was washing their hands really well, and a lot of you that have done their presentations already, you stress about this particular type of of practice of washing the hands very well. So it's something that is very old, but it's still very, very applicable to this field and to preventing disease from spreading. So as a result of applying this in his area, the rate of death of the women and the children, the babies, went down. And so he basically provided this two different scenarios or two different areas where a protocol was different, and then where there was less mortality, he applied that into his area, and this is how he ended up, becoming the father of experimental epidemiology. But you also have heard of this person, right? Some of you have heard of Florence Nightingale, which is, she was a nurse during the Crimean War, and what she did was she volunteered helping in the hospitals, and these are the different cases of disease in the hospital. But the soldiers that were coming back from the war, they had survived, obviously, they came back, but they could die as a result of infectious diseases. So she made also a study, or she conducted a study where she looked at the people that die by wounds through infections, and some were preventable, and compared to all other cases. So she did this, and a lot of things had stemmed from here, from this kind of study. For instance, we have Lister that was the first one to use this carbolic acid, spraying it during surgery to prevent nosocomial infections. So, and this goes back to that question, it's not actually a clinic, but it's sort of like a clinic where you do acupuncture, you go and, there is an intrusion, a source of infection for using those needles, even though they may be sterile, but it may be possible that you can get an infection from that. I think they have very strict regulations about this, yeah.
So much of this, obviously, in retrospect, seems like such obvious stuff, like wash your hands, whatever. What do you think of the things that people are common practice now that will look back, in 20 or 50 years and be like, oh my God, I can't believe they were doing like X or Y in hospitals?
You know what? The thing is, until we do the study, we won't know, right?
But just with your knowledge, are there any things that you feel like, wow, they really need to change the rules around this or that?
Well, one of the things, perhaps, is the use of hand sanitizers. We see hand sanitizers everywhere.
Mm-hmm.
Yeah, we see them outside of computer rooms. And that is changing our microbiome, because it's killing some of our microbiome and maybe picking up, maybe we pick up something that is more pathogenic. In hospitals, it's hard to say. I mean, they try to be very clean and to disinfect everything, and they try to keep the temperature low. Has to do with the machines, but it also has to do with the fact that microbes, they will be stopped when they're in a cold environment, right? Perhaps get more people to work, because when you have less people, then there's more work for those people that are working. Sometimes they forget to change their gloves, they're running from one place to another, maybe they're touching the computers and they just touch a patient, and there's so many things that happen in these places still. I don't know what the answer is, but the main culprit here, or the main source of infection is the staff, is the people that work in hospitals.
Or like the stethoscope they don't clean or
No, they don't.
ever.
No, what I found interesting is that they can isolate if someone has like a MRSA infection, a wound infection. Like outside of those rooms in hospitals, they always have a sink and like soap. Like in other rooms, like where the person doesn't have a wound infection, they have hand sanitizer outside. But like in those rooms, they always say you must wash your hands. Because like wash your hands is better than sanitizer.
Yes.
Wait, can you expand on your sanitizer thing? Like it's killing your hands. Like I don't use it because my hands are really sensitive and they'll just like, I have eczema, they'll just explode if I use it. But can you just expand on that?
It's less effective than washing hands.
It's less effective. I mean, if you're in a place where you don't have access to water and soap, it's better than nothing, right? But soap and water, still the best thing, because soap will disintegrate the plasma membrane of the pathogens and stuff, and even some of the components of the viral envelopes and stuff. But what I was trying to say with using this hand sanitizers is that microbes become resistant to some of those.
Because it's like everywhere.
It's everywhere and you're using it so much, so they become so accustomed that they're just like, yeah. No, seriously, it is something that is not the best thing, and we have changed. We have changed the microbiome by just putting those things everywhere.
Really?
Yeah, we have. This thing is, see, it's not just these guys mutated on their own. We are sort of providing the avenues
Not
for
us
them
helping.
to.
We're the culture.
Yeah. So anyway, it's a lot of stuff, but I don't know, hospitals, you know, the best place to be when you're sick, as long as you're not like a life-threatening condition, best place to be is home. Notice that when you have a surgery, they send you home right away as soon as they're able to, because especially if you had some kind of intervention where there was intrusion, because you can very easily get infected and die. Yes, no. I told you about my mom, right? I didn't tell you about how my mom died.
No,
So she had,
it's not funny.
I'm sorry.
thank you. It was a long time ago. But she didn't like to, she was older. She was in her late 70s, and you know, older people, they don't like to eat a lot, and they take a lot of pills for everything. And so she developed ulcers, right, in her stomach. And then one day she had this strong pain in her abdomen, and she told us. She was also a little bit of a, how do you call that? Anyway, she used to have a lot of things. So sometimes you're like, is she serious or is she really? But we tried because she was older. And so she's like, oh, this is too much, I can't take it. We took her to the hospital, right? And so the doctor said, okay, she has peritonitis. One of her, how do you call it? Her
Intestine?
wounds in the stomach ruptured. And so everything that she ate was going through there. So it spread throughout her abdomen. So she ended up with a bad infection in her abdomen. So the doctor said, if we don't operate, if we don't intervene, she's gonna die. she has to have the surgery, and she never had surgery in her life. So hypochondriac, that was
Wow.
That was it.
so then, oh, I'm so afraid of the surgery. You have to have it, otherwise you're gonna die. Okay. So she went through the surgery and she came out fine. She was fine, you know, they cleaned her up and closed her up. That was on a Friday. Saturday, she woke up okay. In the evening of that Saturday, she had fever and she wasn't feeling well. Then by Monday, I think it was even Sunday, they put her on, they took her to the ICU, put her on a respirator because she couldn't breathe anymore. And then on Tuesday, I was working here, I was teaching at night, and I went to the hospital. And then I go, and she had produced very minimal urine throughout the whole day. And so the doctor told me, you know what this means? Her systems, all of them are shutting down, especially the kidneys. And so you guys have to make a decision. Because, and so imagine, she went with peritonitis, but she died of pneumonia.
That's
She died of pneumonia. That's what happened. Why? Because she acquired pneumonia in the hospital.
Yeah.
And that could happen to anyone with anything, any type of infection, you know, because these things live there. And so the best thing is, if you have, and doctors avoid surgeries as much as possible, that's like the last resource. They try to treat it with something, therapies, whatever, but if it's necessary, then they go for the surgery and they send you home as soon as possible. Because these things live in the disinfectants on the surfaces. Anybody who comes and touches a door, I mean, these things are there. And who can control that? I mean, they try, to go back to your question. Hospitals try, you go and the floors are so clean, everything's like sparkling clean. But the things that you don't see, those are the things that. Yeah, so we have analytical epidemiology that is, it consists of a couple of studies. You can have retrospective studies or prospective studies. And retrospective studies is looking at that historical data and use it to sort of identify patterns and see if you can prepare for whatever is coming, because these things are not going anywhere. And then prospective studies gather data, and they use, same thing, they use some of this data to sort of associate or to relate to future diseases. Remember, and you create models. Remember the models that Cuomo used to talk about on TV?
Oh yeah,
this
didn't
is
he have like a
this
mountain? He had like a
Yes.
paper mache mountain.
I think I have it somewhere in here. I have it somewhere. Anyway,
Oh.
so you use models to predict how the disease is going to behave according to the data that you have, according to the behavior of people. And so he used to say, okay, so we're here right now, 900 people per night dying, but if we start practicing the 6 meter or 6 feet, distance, we start using the mask and other things, isolate if you have symptoms and whatnot, then that curve is going to flatten, right? It eventually did, flattened, but that was also because then we started vaccinations and all of that. So we're going to look at some of the modes of transmission that are involved in the spread of disease, contact vectors and vehicles or modes of transmission. Look at some of the vectors, and we'll talk about nosocomial infections. So the type of infection that my mom had was, yes, a nosocomial infection, but it was a different type of nosocomial infection, iatrogenic infection, because that one involved a surgery, some procedure, some kind of procedure in the hospital. So, in terms of sources of infection and carriers, we are reservoirs of infection, right? We may carry it, right? But we may not have symptoms, okay? I remember when, you guys were too young, but I remember in the 1980s and 90s, some people were infected with HIV, and they did not disclose because of all of the, prejudice and stuff that was going on. Will not disclose that they were infected, and they went infecting others. And so passive carriers could be, something that applies to us, can mechanically transmit to another host. We have active carriers.
Is that like Typhoid Mary? Was she an active carrier of that?
She was an active carrier. So she did not, so did you hear? Which mentioned?
Typhoid Mary. It's
Typhoid
like
Mary?
that
Everybody
story.
familiar with Typhoid Mary?
fake.
No, it seems like some of you are not. Can you, one of you?
Tell us.
You
What?
wanna?
No, I think you'll be the better expert.
Okay.
All I know is she had typhoid, but she didn't know she had it, and she just kept spreading it, and then they sent her to like an island or something.
They told her one time because she was taking care of children she was like a babysitter for taking care of young children, and like a lot of the children she was taking care of, they got typhoid fever and they died. So then the State Department actually discovered her, tested her. They said, "Oh, you're a killer of typhus fever. Don't work with children. Don't work in a position whereby you can spread the disease to others." Well, she still had to work, so eventually she became a cook, and she was spreading it.
And she dreamed about being a cook all her life.
Yeah.
She was an Irish migrant.
Yeah. And then eventually they found her again, and then they took her away and they put her in quarantine forever.
Yeah.
Yeah.
And she died in, is
Long
that North
Island.
Brother Island?
Yeah,
Wait,
one
so
of
she
those
just
islands.
moved on an island?
Yeah.
They put because I don't think they had medicine.
That's
for
kind of a
it
dream,
back
though.
then. It was not a dream for me.
So she spread through her cooking. Because why? She used to go to the bathroom and not wash her
That's
hands.
so embarrassing.
Well, a lot of things were true of, things like this long time ago. At least we kind of have learned, the majority of us have learned to. How many of you have gone to the bathroom here and you notice someone comes in and doesn't wash their hands?
Disgusting.
And then they go and open the door. After I wash my hands, that's why I usually have a piece of paper and open that door, right? Because this is how they get transferred, these diseases. Anyway, so Typhoid Mary was an active carrier. We have asymptomatic carriers, active carriers who do not present signs or symptoms of the disease despite the infection. And that was her too, because she really didn't display any symptoms. She didn't get sick, but she carried the virus. All right, so other things that are possible sources of transmission and reservoirs and carriers. Again, humans with AIDS and a lot of STDs, gonorrhea, syphilis, all of these diseases that are transmitted through sexual contact. Some people may have apparent sort of signs that they are infected, like if you have you're in contact with someone who may have cold sores or something, and you have an intimate relationship, you may end up carrying that herpes virus with you on the way home. Anyway, animals, remember zoonosis, right? that transfer these diseases. And we can also include here some of the mosquitoes and other arthropods, not just the ticks, but rabies that is transmitted sometimes by a cat or a raccoon or
Dogs
one of the.
dogs are actually the prime carriers for that. So we should leave the bats out of it.
That's all we're gonna look at.
Yeah, bats have other problems.
Yeah.
Yeah, poor things. So yeah, anything that is transmitted to humans through animals, those are zoonoses. Non-living, this is the answer to that question. Remember? Some of you asked me
Yes.
about.
Yeah,
You got it?
I told you. Yes.
Non-living,
Yeah, soil.
okay? Because these things remain in the soil for hundreds of years, even. The spores of Clostridium, right? Clostridium tetanus, Clostridium botulinum, many other types of bacteria that produce spores. Maybe you guys can watch this. When you click on this, you can watch it. Contact transmission, direct contact transmission requires close association with the infected individual, right? So, of course you're going to do this. She can't walk out on her own. So you hold your kid who has been in daycare, and then she's touching the toys and touching everything. Comes home, those toys were touched by a kid that had the runny nose and all of that. And guess what? The father is not gonna get sick. Mita is gonna get sick. That's how it usually happens. Grandma is the one that gets sick because her immune system is sort of suppressed. He's healthy. Anyway, so these things can be transferred through, as you know, the mucous membranes, through contact. And then they could be transferred from one host to another, the mouth, the eyes. Rhinoviruses are transferred like this, by contact. Mucous membranes, surfaces that may have some of those bodily liquids, fluids, you touch them and then, 2 days later you end up with, a cold. Fomites, okay? This is indirect transmission through fomites. Fomites are things such as the doorknobs. You go to the beach or to the gym and you put your towel there, maybe somebody had their towel there and maybe they have, I don't know, some weird stuff in there and they left something there. Syringes. A lot of people got HIV, not because they had a sexual encounter with somebody, but because they shared needles with someone who was a drug addict, perhaps. And these are very common examples. I told you about that doctor, that professor that used to study, he used to teach here, and he got infected by a fomite, a syringe, got sort of of someone who had HIV. Contact transmission through droplets, very common as well. Vertical direct contact transmission, and this is through the placenta, through, when from mother to baby, through breastfeeding. Congenital transmission during the delivery from the mother to the fetus, and spoke about syphilis, right? No, Neisseria gonorrhea being transmitted like this when the mother is infected with that particular disease. Fecal transmission. This is through other means, how the disease is transmitted. Through air, water, giardia, right? Through air, hantavirus. the Synombre virus. Anybody familiar with the Synombre virus? No, it happened in the 1990s in the it's also called the Four Corners virus.
Oh, that was like in Nevada or like New Mexico?
Nevada, New Mexico, Utah, and what's the other one?
Colorado.
Arizona. Yeah, so what happened was, and it was very similar to hantavirus, and it popped up in this Indian reservation. And so look how it was linked to 2 years before to El Nino effect. Everybody knows what's El Nino, right? Okay, so El Nino happened, right? Then the following year, so El Nino we used to think that it only affected South America, but it affects the entire globe, all of the currents, right? And so what happens, and so it affects the temperatures and the climate all over. So it rained 1 year, the following year there was rain in the desert of that area, those states. And you don't have a lot of precipitation in those areas because they're very dry. You had a lot of precipitation, so what happened? All that water sort of fueled the plants to bloom, and right? And then the mice were happy because they had a lot of food. So they had a party. And so they ate and they did other things, and they had a lot of babies. And guess what? Those mice were all over the reservation, and so when people were sweeping their houses and stuff through the air, they got the virus, and so they got infected, and they were dying from inside, like drowning in their own fluid. Their lungs were full of fluid, and very similar to hantavirus, just some kind of gets a variation. So that was 2 years ago. Climate shaped what happened in this area 2 years later. Anyway, so air, water, food. You cut your chicken, you're making food. Do you wash your chicken?
Yes.
Wash the chicken?
I do. Yeah.
Do you wash the chicken when you make it?
I washed it before.
No?
Yeah.
So
Before, like after.
So you're following the
Not
USDA.
so.
You're following what the government said last, not to wash your chicken because you're spreading salmonella and other things on your sink. Well, I'm sorry, but I do wash my chicken. I can't. I'm used to. So here's the thing. Some people may cut their meat or their veggies with the same knife, on the same cutting board. At least turn it over and rinse that knife. Because you're transferring things into your food. Yeah, no, but it happens. So that's another way that food gets contaminated. Oh, and let's not talk about these food bars.
Oh, okay.
What? So in those places, these were very popular. I'm gonna stop on this one. Very popular in the 80s. I remember because they opened one in the back of this building, Yips, that was the name. They opened this. But imagine, first, the people that cut the vegetables and stuff, do they all wash their hands after they go to the bathroom and come back to cut the letters or all of this? Then you come and here there's this glass. But you come and you're talking to your friend, oh yeah, so how was your weekend, blah, 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 blah. And things are, okay, so those are other sources of infection, all of these things. We don't think about it, but they are. I'll pick up on slide number 26 on Friday, and we'll finish it, okay? All right, here's